let us study types of matrices. So there are some types of matrices. The first type of matrices is column matrix. How to define a column matrix? A matrix having only one column is called a column matrix. For example, this is a matrix 2, 3, 4. This is a matrix which has only one column. Therefore, this is called a column matrix. Second type is a row matrix. Row matrix is defined as a matrix having only one row is called a row matrix. See, this is a row matrix because it has only one row and columns 3. We need not worry about the number of columns. Number of row is 1. Therefore, this is called a row matrix. And the third type is square matrix. So, how to define a square matrix? A matrix is said to be a square matrix if the number of rows is equal to number of columns. Then that matrix is said to be a square matrix. So, let me consider one example. C equal to 2 minus 1, 7, 5. Now, this is a square matrix of order 2 cross 2 because this is a square matrix because number of rows 2, number of columns 2. So, number of rows is equal to number of columns. Therefore, this matrix is called a square matrix. And even 3 cross 3, 3 minus 1, 0, 2, 7, 5, 0, minus 2, minus 3. This is a matrix of order 3 cross 3. Therefore, this is an example for a square matrix because number of rows is equal to number of columns. The next type is diagonal matrix. Diagonal matrix. Now, you can observe in example C and the matrix D. So, two diagonals we have, two diagonals. We call this diagonal as principal diagonal. Principal diagonal 3, 7, minus 3 are the elements lying on principal diagonal. So, this diagonal is called principal diagonal. So, the elements other than principal diagonal elements are called non-diagonal elements. So, these 3 are called diagonal elements and the rest 6 elements are called non-diagonal elements. Then how to define a diagonal matrix? A matrix or a square matrix. If I say a matrix, usually this in the examination that you can expect one more question like define a scalar matrix, define a diagonal matrix, define a square matrix. Usually we commit mistake in diagonal matrix, we start a matrix. It is not a matrix. Diagonal matrix, it should be a square matrix. You cannot define a diagonal matrix if it is not a square matrix. So, diagonal matrix is a square matrix. That is the basic condition, necessity condition of a diagonal matrix. It has to be a square matrix. So, a square matrix in which all the non-diagonal entries are 0 is called a diagonal matrix. So, diagonal matrix is a square matrix in which all the non-diagonal entries are 0. So, 2 is a diagonal entry, therefore, this cannot be 0. 0, non-diagonal entry, 0, this place again non-diagonal entry, and this is second row, second column is a diagonal entry. So, it cannot be 0, non-diagonal entry, 0, non-diagonal entry, non-diagonal entry, diagonal entry, So this is an example for a diagonal matrix. So a diagonal matrix is a square matrix in which all the non-diagonal entries are 0. Now let me define a scalar matrix. How to define a scalar matrix? There is a connection between square matrix and a diagonal matrix, and again there is a connection between diagonal matrix and a scalar matrix. How to define a scalar matrix? A diagonal matrix is said to be a scalar matrix if the diagonal entries are equal. See, to define a diagonal matrix, it should be a square matrix. To define a scalar matrix, that matrix should be a diagonal matrix. Diagonal matrix should be a square matrix. Therefore, scalar matrix should be a square matrix. So, to define scalar matrix, a diagonal matrix is said to be a scalar matrix if diagonal entries are equal. So, example for a scalar matrix, see, it is a diagonal matrix, therefore it should be a square matrix also. So 2 0 0 0 2 0 0 0 2 is a scalar matrix. Why this is a scalar matrix? Because this is a diagonal matrix in which the diagonal entries are equal. This is principal diagonal, diagonal elements. So diagonal elements are equal. Therefore, this is called a scalar matrix. The next type is identity matrix. How to define an identity matrix? A diagonal matrix in which each diagonal entry is 1 is called an identity matrix or unit matrix. So to define an identity matrix, it should be a square matrix and diagonal matrix. So a diagonal matrix in which each diagonal entry is 1 is called a unit matrix or identity matrix, and the next type is 0 matrix. We define identity matrix with the help of a diagonal matrix, and we denote identity matrix as capital letter I. So identity matrix is denoted by capital letter I. How to define a 0 matrix? A square matrix in which each entry is 0 is called a 0 matrix, or we define it as a null matrix also. A null matrix or a 0 matrix is a square matrix in which each entry is 0. One more type is upper triangular matrix and lower triangular matrix. So, triangular matrices. How to define triangular matrices? In triangular matrices, we have two types. The first type is upper triangular matrix and the second type is lower triangular matrix. So, triangular matrix is a matrix in which all the elements above the principal diagonal or below the principal diagonal are 0 is called a triangular matrix. For the time being, let me consider an example. A 2 0 0 1 7 0 6 0 4. In this example, you can observe 2 7 4 are diagonal elements. All the elements above the principal diagonal. So this is principal diagonal. All the elements above the principal diagonal are zeros. Therefore, this is called a triangular matrix. This is called a triangular matrix. Now let me consider one more example. B is equal to 7 4 0 0 minus 1 2 0 0 8. In this example, all the elements below the principal diagonal are zeros. Therefore, A and B are called triangular matrices. In A, all the elements above the principal diagonal are 0. In B, all the elements below the principal diagonal are zeros. Therefore, A and B are called triangular matrices. Triangular matrices, you can define in a triangular matrix. There are two types. The first type is upper triangular matrix and the second type is lower triangular matrix. How to define an upper triangular matrix and a lower triangular matrix? A matrix in which all the elements above the principal diagonal are zeros is called a lower triangular matrix. So, A is a lower triangular matrix because all the elements above the principal diagonal are 0. Therefore, A is a lower triangular matrix, and with respect to B, all the elements below the principal diagonal are zeros. Therefore, this is called an upper triangular matrix. So, lower triangular matrix, all the elements above the principal diagonal are 0. Upper triangular matrix, all the elements below the principal diagonal are zeros. So, next, after these types of matrices, let me consider equality of two matrices. Equality of two matrices. When two matrices are said to be equal, two matrices are said to be equal, the first condition is, suppose we have two matrices A and B. When you can say a matrix A is equal to matrix B, we have two conditions. First condition, both A and B, they have the same order. Suppose order of A is 3 cross 2, then order of B should be 3 cross 2. Second condition, each element of A is equal to corresponding elements of B. So, each elements of A is equal to corresponding elements of B. So, elements of A equal to corresponding elements of B. Then only we can conclude that A and B are equal. So, corresponding elements of B. These two conditions, if you can satisfy, or if two matrices satisfy these two conditions, then we can say two matrices are equal. For example, A is equal to 2, 1, 0, 7 and B is equal to 2, 1, 0, 7. Now, A and B are equal because order of A is 2 cross 2, order of B is also 2 cross 2, that is first condition. The second condition, each element of A is equal to corresponding elements of B. See, 2 A11, in B A11 is again 2, so 2, 2, 1, 1, A22 of A is equal to A22 of B, A21 of A is 0, A21 of B is 0. So, A11, A12, A21, A22 of both A and B are equal. Therefore, these two matrices are equal and we denote as A is equal to